Imagine standing in a storm powerful enough to rip trees from the ground and peel roofs off entire neighborhoods. Now think about this. A single roof shingle, only a few millimeters thick, can help protect a home against winds exceeding 130 miles per hour. Most people walk past thousands of shingles every day without ever wondering how something so ordinary becomes one of the most important shields in modern construction. And what you're about to see is far more complex than anyone expects. Today we're following a complete journey of a roof shingle from raw earth materials to the rooftops of millions of homes around the world. You'll see giant mines, roaring factories, rivers of molten asphalt, precision coating systems, and testing machines designed to simulate decades of weather in only a few weeks. But here's what nobody tells you. The most important ingredient doesn't come from a forest, a farm, or even a factory. It comes from deep underground. Every year, manufacturers produce billions of roof shingles, enough to cover entire countries with protective layers against rain, snow, sunlight, and hail. Yet each shingle begins as a combination of minerals, petroleum products, fiberglass, and colored stone granules sourced from multiple continents. What happens next surprised even experienced engineers when modern production lines began pushing output to astonishing levels. And the first stop on this journey starts thousands of feet below the Earth's surface. Most modern asphalt shingles rely on four major ingredients: asphalt, fiberglass mat, mineral fillers, and colored ceramic-coated granules. The asphalt often originates from petroleum refining operations in countries like the United States, Canada, and Saudi Arabia. Fiberglass begins with silica sand mined from deposits that can contain more than 95% pure silicon dioxide. Those materials may travel hundreds or even thousands of miles before they ever meet on a factory floor. Think about this. The asphalt that waterproofs your roof starts as crude oil extracted from deep underground reservoirs. Refiners separate crude oil into gasoline, diesel, jet fuel, and dozens of other products through towering distillation columns. What remains after many valuable fuels leave the process becomes a thick, black material known as asphalt flux. It looks like liquid midnight and carries the unmistakable smell of hot petroleum. Meanwhile, another ingredient follows a completely different path. Silica sand from mines in states like Illinois and Wisconsin enters glass manufacturing facilities where furnaces exceed 1,500 degrees Celsius or 2,732 degrees Fahrenheit. The sand melts into glowing liquid glass before machines stretch it into incredibly thin fibers. These fibers eventually form the fiberglass backbone that gives shingles their strength. Most people never think about the colored granules covering the surface of a roof. Those tiny particles begin as crushed volcanic rock, granite, or other hard stone mined from quarries across North America. Workers crush, screen, wash, and sort the rock into carefully controlled particle sizes. Then manufacturers coat the granules with ceramic pigments designed to survive decades of sunlight without fading. Here's the shocking part. A typical roofing granule may spend more time being processed than the stone itself spent being extracted. Manufacturers fire these granules in specialized kilns at temperatures approaching 650 degrees Celsius or 1,202 degrees Fahrenheit, permanently bonding color to the surface. Without this step, rooftops around the world would quickly lose their appearance under years of ultraviolet exposure. All these ingredients converge through a vast transportation network of rail cars, trucks, barges, and storage terminals. Some materials travel more than 2,000 miles before reaching a roofing plant. Supply managers coordinate deliveries with extraordinary precision because even a short interruption can stop an entire production line. But moving the materials is only half the challenge. Environmental concerns shape every step of the journey. Modern plants recycle mineral waste, reduce energy consumption, and recover heat from manufacturing processes that once released enormous amount of energy into the atmosphere. Some facilities even reuse production scrap directly inside new shingles. Yet despite all these improvements, the industry still faces one enormous challenge waiting inside the factory walls. Because the moment these ingredients enter the manufacturing line, temperatures soar, machines thunder to life, and hundreds of tons of material begin moving every hour. Rivers of molten asphalt will soon coat a fiberglass sheet with astonishing precision. And this is where the story becomes truly extraordinary. The moment raw materials enter the factory, the atmosphere changes completely. Massive pumps begin pushing asphalt through insulated pipes while giant motors shake the building with a deep mechanical rumble. You can hear conveyor belts moving from hundreds of feet away. The air feels warmer, heavier, and carries the unmistakable scent of heated petroleum. The first major step begins with a fiberglass mat. Rolls weighing thousands of pounds unwind continuously into production line. Precision rollers pull the mat forward at speeds reaching 100 meters per minute, creating an uninterrupted stream of material. Every inch must remain perfectly aligned because a tiny deviation now could become a major defect later. Now comes the stage that defines the entire product. Asphalt is heated to approximately 205 degrees Celsius, or 401 degrees Fahrenheit, until it reaches the ideal coating viscosity. Huge pumps move the material through heated systems, while temperature sensors monitor every second of the process. The glowing black liquid flows like a river of molten glass, except this river will eventually protect homes from decades of storms. The fiberglass sheet enters a coating station where molten asphalt surrounds it from both sides. Massive rollers operating under carefully controlled pressure squeeze the layers together. The process lasts only a few seconds, but it determines the waterproofing performance of the finished shingle. What happens next surprised even experienced engineers when they first witnessed the scale. Hundreds of kilograms of mineral filler suddenly enter the asphalt coating mixture every minute. Finely ground limestone improves durability, stiffness, and cost efficiency. Powerful mixers rotate at hundreds of RPM while blending materials into a uniform composite. The sound resembles a continuous thunderstorm trapped inside a steel chamber. Before the asphalt cools, ceramic-coated granules rain down from overhead hoppers. Thousands of colorful particles strike the hot surface every second, instantly embedding themselves into the asphalt layer. The impact creates a mesmerizing wave of movement across the production line. Most people see these granules as decoration, but they actually serve as armor against sunlight and weather. Think about this. Without these granules, ultraviolet radiation would slowly destroy the asphalt beneath. The granules act like billions of tiny shields protecting every square inch of the roof. Manufacturers carefully control coverage rates to ensure complete protection. Even a small uncovered area could reduce long-term performance. Next, cooling sections stretch across the factory floor. Powerful fans force air across the hot material, while cooling drums extract excess heat. Temperatures gradually drop from over 200 degrees Celsius to safe handling levels. You can actually see waves of heat rising into the air as the product begins transforming from a liquid-coated sheet into a solid roofing material. But here's where precision becomes critical. Automated cutters must slice the continuous sheet into exact shingle dimensions while moving at production speeds. Computer-controlled blades operate with millimeter-level accuracy. A single line can produce thousands of shingles every hour, yet each piece must remain virtually identical to the next. Special stamping rollers then create the familiar tab patterns and textures seen on rooftops around the world. Pressure, timing, and alignment must remain perfectly synchronized. The machines move with astonishing speed, stamping thousands of patterns every hour. Watching the process feels almost hypnotic. Workers constantly patrol the line despite the high level of automation. They listen for unusual sounds, inspect material flow, and monitor control systems. Experienced operators can often detect a developing problem before sensors trigger an alarm. And this is one reason human expertise still matters inside even the most advanced factories. Finally, robotic stackers collect finished shingles and arrange them into bundles for packaging. Conveyor systems move the bundles toward wrapping stations where protective packaging prepares them for transport. Within only a few hours, raw minerals, fiberglass, and asphalt have transformed into a product capable of surviving decades outdoors. But can every shingle truly meet that promise? Because before a single bundle leaves the factory, engineers subject these shingles to brutal tests designed to simulate years of punishment from wind, rain, hail, sunlight, and extreme temperatures. And some of those tests are so severe that they destroy the product completely. That's where we're headed next. The manufacturing line may look unstoppable, but producing millions of shingles means absolutely nothing if even a small percentage fail in the real world. That's why modern roofing plants invest millions of dollars in inspection technology. Every second, Cameras, lasers, sensors, and computers examine products moving at incredible speeds. Most defects are detected long before a human eye could even notice them. As finished shingles move along the conveyor, high-speed machine vision systems capture hundreds of images every minute. Artificial intelligence compares each product against reference standards stored inside industrial computers. The software searches for cracks, coating defects, missing granules, dimensional errors, and color inconsistencies. What happens next takes place faster than the blink of an eye. The moment a defect appears, automated reject systems activate instantly. Pneumatic actuators or robotic mechanisms remove the faulty product from the line without slowing production. Some facilities inspect thousands of shingles per hour while maintaining rejection rates below 1%. The goal isn't simply speed. The goal is perfection. Laser measurement systems add another layer of protection. Invisible beams scan the thickness and dimensions of every product with tolerances often measured within fractions of a millimeter. If a shingle becomes slightly too thick, too thin, or improperly shaped, alarms alert operators immediately. Most people never realize this level of precision exists inside a roofing factory. But dimensional accuracy is only the beginning. Engineers regularly collect samples and move them into specialized laboratories hidden inside the facility. Here, the atmosphere feels less like a factory and more like a scientific research center. Every test asks a simple question. Will this product still perform after years of punishment from nature? One of the most dramatic tests simulates hurricane-force winds. Large wind tunnels blast shingles with air speeds exceeding 200 kilometers per hour or 124 miles per hour. The noise becomes deafening as powerful fans attempt to lift and tear the material apart. Watching the test feels like witnessing a controlled natural disaster. Then comes hail resistance testing. Steel balls or specialized impact projectiles strike the shingles at carefully controlled speeds designed to mimic severe storms. The impacts create explosive sound that echo throughout the laboratory. What happens next often surprises visitors because many premium shingles survive repeated impacts without catastrophic damage. Ultraviolet weathering chambers attack the product in a completely different way. Powerful lamps simulate years of sunlight exposure in a matter of weeks. Engineers measure color retention, flexibility, and surface degradation throughout the process. What takes nature decades can be reproduced inside a laboratory faster than most people imagine. Extreme temperature chambers push the material from blistering heat to freezing cold. Some tests cycle between temperatures below -30 degrees Celsius and above 80 degrees Celsius. The repeated expansion and contraction reveals weaknesses that might otherwise remain hidden for years. Every successful test increases confidence that the roof above your head can survive the unexpected. International certification organizations establish strict performance requirements before products can enter many markets. Manufacturers routinely test according to standards for fire resistance, wind resistance, weather performance, and durability. Passing these certifications requires extensive documentation and verification. The paperwork alone can fill entire rooms. And this is where human skill still beats machines. Experienced inspectors often identify subtle visual patterns that algorithms haven't yet learned to recognize. Years of hands-on experience allow them to notice tiny changes in texture, coating appearance, or granule distribution. Even in an age of artificial intelligence, human judgment remains one of the most valuable quality control tools in the factory. Because every year, manufacturers produce enough roofing material to cover entire cities, employ hundreds of thousands of workers, and generate billions of dollars in economic activity. And some of the statistics you're about to hear sound almost unbelievable. By the time a bundle of shingles reaches a construction site, it has already completed a journey involving mines, refineries, factories, laboratories, warehouses, and transportation networks spanning entire continents. Yet the truly astonishing part is the scale. Every year, the global roofing industry produces billions of square meters of roofing materials. If placed side by side, the annual output could cover entire metropolitan regions. The global roofing materials market now generates well over $100 billion annually, with asphalt shingles representing one of the largest segments in residential construction. North America remains a dominant market for asphalt roofing products, particularly in the United States and Canada. Millions of homes depend on these materials every single day. Most people never realize that one of the world's largest manufacturing industries sits quietly above their heads. Today, the top roofing markets include the United States, China, India, Canada, and Germany. Together, these countries account for a huge portion of global roofing production and consumption. Rapid urban development, population growth, and infrastructure investment continue driving demand higher every year. And this trend shows no signs of slowing down. Think about this. Hundreds of thousands of workers worldwide participate directly or indirectly in roofing manufacturing. Miners extract raw materials. Refinery operators process petroleum products. Engineers design production systems. Technicians maintain equipment. Truck drivers, laboratory specialists, and construction crews all contribute to a single product that many people barely notice. The story of roof shingles stretches back much further than most people imagine. Early roofs relied on wood, clay, slate, and thatch. Asphalt shingles emerged during the late 19th and early 20th centuries as manufacturers searched for affordable, durable alternatives. What began as a simple roofing solution eventually evolved into one of the most advanced building materials on Earth. 50 years ago, many roofing plants relied heavily on manual operations. Workers handled materials directly. Quality inspections depended largely on human observation, and production speeds were dramatically lower. Today's factories use robotics, artificial intelligence, automated controls, and real-time monitoring systems capable of making thousands of decisions every minute. And this is where it gets truly extraordinary. Researchers are now developing advanced roofing systems with improved energy efficiency, enhanced durability, and greater environmental sustainability. Some experimental products can reflect more solar heat, helping reduce cooling costs in hot climates. Others incorporate recycled materials without sacrificing performance. Did you know that a quality asphalt roof can protect a home for more than 30 years? Did you know that modern roofing granules help block ultraviolet radiation that would otherwise damage the asphalt beneath? And did you know that some roofing products undergo accelerated weather testing equivalent to decades of real-world exposure before they ever reach the market? What happens next may define the future of the entire industry. Over the next decade, analysts expect growing demand for sustainable construction materials, smarter manufacturing systems, and increasingly automated production facilities. Factories will become faster, cleaner, and more efficient than ever before. But the fundamental mission will remain exactly the same: protecting homes from the forces of nature. From deep underground petroleum reserves to giant refineries, from glowing fiberglass furnaces to roaring manufacturing lines, we followed an incredible journey hidden behind a product most people never think about. Every shingle carries the work of miners, engineers, scientists, machine operators, logistics experts, and quality inspectors. What seems ordinary from the street is actually the result of extraordinary engineering. The next time you see a rooftop during a storm, you'll know the hidden story beneath those rows of shingles. You'll know about the rivers of molten asphalt, the microscopic fiberglass strands, the ceramic-coated granules, and a relentless testing that ensures long-term performance. Most people see only a roof. You now see an entire manufacturing ecosystem. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.